analytic functions also, but today's topic is complex functions. So let us begin our study of complex analysis from the complex function. So as we know, what is a function? Function is nothing but a rule. What is a function? Function is a rule which assigns each element in the set of in some set. In real analysis, we used to call that set as domain, but in complex analysis, domain has got some topological sense. So I will simply write in complex analysis a function from a subset A of C to a subset B of C. So basically all these A and B, whatever A and B have written, these are two non-empty subsets of C. Then what is a complex function? A complex function from A to B is a rule which assigns each Z naught, let us say Z naught is some X naught plus iota Y naught belongs to A. What does it assign? A unique element in W naught, let us say, which is equal to iota naught plus, sorry, U naught plus iota V naught in B. This W naught is referred to as the value of function at Z naught. However, we'll see that this uniqueness may or may not be possible. So in complex analysis, we have a concept of multivaluedness. Okay, we have a concept of multivaluedness. But for starting, I've just defined a complex function of a complex variable is nothing, but it is defined from A to B. So basically, it is defined from Z to W. And it is a rule which assigns every element in the set of A to the element in B. It may or may not be unique because there are possibilities, let's say logarithmic function and other functions which are multi-valued also. But for the starting, I have defined it this way. So what would be W? W would be nothing, but it will contain two parts. It will contain real part of Fz plus iota, imaginary part of Fz. Okay, so what will W contain? The image of Z will be again an ordered pair. The image of Z would be again an ordered pair. And obviously, you can visualize it in this fashion, that if you're taking some element Z in A, and if you're, let's say this is somewhere in the region A, and let us say this is some X comma Y, you map it, and this is some region W plane, okay? And here it will be some U plus U comma B. So what is U? U is nothing, but it is a real part of Fz. And what is V? V is nothing, but it is the imaginary part of Fz. So in complex analysis, we map an ordered pair to an ordered pair. So this is a mapping from ordered pair to an ordered pair. Okay, so for example, let us take one example. Let us say, how would 1 over Z map? So you know that what is the domain of definition for this? It will contain all the complex numbers except 0. So if you take a subset A of all the complex numbers except 0, and let us say this number is X comma Y, then how it get mapped? It would get mapped to another plane, let's say W plane, this is a Z plane. And here it will map to what? It will map to 1 over Z. And what is 1 over Z, by the way? 1 over Z is Z bar divided by mod Z whole square. And what is Z bar? Z bar is X minus iota Y divided by X square plus Y square. So basically it will get mapped to X upon X square plus Y square, comma, minus Y upon X square plus Y square. So basically this point. So if this is X comma Y, under the transformation Fz is equal to 1 over Z, this will get mapped, this point x comma y will get mapped to x upon x square plus y square comma minus y upon x square plus y square. So again, you can visualize an ordered pair getting mapped to an ordered pair. Is that fine till now?
Yes, sir.
Okay, so I hope it is clear. So in general, we'll use this notation. So what is fz? Fz is also nothing, but it is an ordered pair of two real valued functions, right? So what is fz? Fz is nothing, but it is ordered pair of two real valued function. Nothing is complex here, okay? Real valued function. So basically, what is fz? Fz, let's say z is some x plus iota y. We take the function of it, so we assign a rule, and it is equals to, let say u would be some function of xy plus iota v as a function of xy. So basically, what is fz? Fz, this u is nothing but is the real part of fz, and what is v? V is nothing but it is equals to imaginary part of fz. And what both real part and imaginary part of fz are nothing but they are contained in R square. So this u comma v is contained in R square. Is that clear? So fz is nothing but it is ordered pair of two real valued functions. Is that fine? So basically, what is u? U is nothing but it will be defined from a to r square. If function is defined from a to b, and similarly, v will be defined from a to r square. Sorry, r, not r square. And function fz would obviously be some u plus iota v. So you can visualize this function in r square. You can visualize this function in R square, somewhere in R square. So basically, this fz can be visualized as a set, as a subset in R square. Is that fine? So basically, you have to just realize that the function of z is nothing but an ordered pair of real part of fz and imaginary part of fz. And we know from our initial classes, we've already seen that there exists an isomorphism between C and R square. So you can visualize your function as in R square, that is as an ordered pair of two real valued functions. You'll find lately that you can also write your function in the polar form. So basically, if you have some z as r comma theta, then also you can write function in form of both r and theta. So you'll see lately that at times it is easier to work with the polar coordinates also. So let us say if I have function fz is equals to 2z square minus z plus 1, where z belongs to complex number. So how would you write fz? You already know that z is equal to what? Z is equal to x plus iota y. So clearly your fz, if I want to express it in form of two ordered pair of two real functions, I will write 2 times x square minus y square plus 2 iota xy. This is something that you know, minus x plus iota y plus 1. Is that fine? Z is x plus iota y, z square is this, you know already from your basic classes that I've already taken. So overall, you know I can write it in this form, x square minus y square minus x plus 1 and plus iota. This will be 2xy. Sorry, this will be, I think, 4xy by the way. And this will be, I think, minus x by 2, then I should write. Sorry. Okay, this will be iota 4xy, and this will be minus of, I think, y. Is that fine? So this is what? This is your vxy, and this is your uxy. Is that fine or not fine?
Yes, sir.
Your fz is nothing but ordered pair of two real valued functions only. You can as well write in form of complex, in form of what? In form of polar coordinates also. You know from your basic classes that any z can be represented as r into e to the power iota theta, where r is nothing but it is equals to modulus of z, and theta is nothing but it is equals to argument of z. So if you use this expression this way, then, and also you know that what is x. So if you really want to extract x in form of polar coordinates, x is r cos theta, And if you really want to extract y in form of polar coordinates, it is y is equal to r sine theta. So you know that your fz is equals to some real part of fz plus iota times imaginary part of fz, right? And what is real part of fz? So real part of fz is 2 times x square minus y square. So 2 times cos square theta minus sine square theta. And some r square also accompanying it. Okay, so 2 will come also. Minus x by 2. X by 2 would be r cos theta divided by 2 plus 1 upon 2. And plus iota times f imaginary part of fz. Imaginary part of fz would be equal to 4 r square cos theta sine theta minus r sine theta. Is that fine? So you can also express your function in form of both r and theta also. So this is also another way of expressing the same thing. So 2 times cos square minus sine square, you already know this is, I think, cos 2 theta. You already know this is cos 2 theta. So this is 2 r square cos 2 theta minus r cos theta plus 1 plus iota. And you know that this is 2 sine theta cos theta sine 2 theta. So I'll simply write 2 r square sine 2 theta minus r sine theta. So this is how you can express your function in form of r and theta also. So here u is expressed as a function of r and theta. V also is expressed as a function of r and theta. One has to again pay attention that this function is nothing but ordered pair of two real functions. It is an ordered pair of two real functions u and v. Is that fine?
Yes, sir.
Okay. So for every z, that is x plus iota y, in the domain of definition of the function, we can assign certain values in another plane. So they basically, we are mapping here from one plane to another plane. Is that fine? So we are mapping from one plane to another plane. We can tell this as z plane, we can write it as a w plane, or whichever other notation suits you, but this is how it is. So for every z, which is x plus iota y of the domain of definition in the z plane, according to the function, according to the rule, we can assign u, which is the real part of f, v, which is the imaginary part of f, and we can plot it in another plane. So basically, this is plane to plane sort of mapping. Okay. Now let us say that if f is defined on, A, and if I take certain values s, which is subset of A, then what is fs? Fs is nothing but it is functional value of all those z, where z is contained in S. And this Fs is called as the image of F. Image of F under the set S. Okay. So if S is a subset of A, and if F is defined on A, so let us say F is defined from A to B. If S is a subset of A, and I'm finding the values of Z, where Z belongs to S, these values are called as the image of F under set S. And what is the range of F? If I take all the values of under A, and if I find the image of all these values, this is called as the range of F. All these things you know from your standard 12th also, but still just telling you. Okay, is that fine?
Yes, sir.
Okay. Now, there is a concept of multivaluedness and single valuedness here. So there is a concept of multivaluedness and a single valuedness in this entire thing. So as we know that in complex analysis, every complex number except 0 can be uniquely written in form of the polar coordinates, can be uniquely written in the form of polar coordinates. You know that every complex number we can write uniquely in the form of polar coordinates. except 0. So basically the complex number can be written as z is equals to r e की power iota theta, where r is what? It is equals to modulus of z, where theta is equals to what? You can take principal argument also, and you can take argument. So let us take principal argument, and you know that principal argument lies between minus pi to plus pi. So every complex number, if I'm taking the principal argument, okay, so that will restrict one possibility that you cannot come to a point two times. So basically, if I'm using a principal argument, then what happens? If I'm saying this particular number, so you can assign, let's say this is equals to pi by 4, and let's say this is 1. So you can write 1 comma pi by 4 here. If I'm assigning a principal argument. If I'm not assigning a principal argument, then what you can do? You can always come back to this point saying that no, this will be equals to 1 plus 2 pi plus pi. So right now, I'm defining z is equals to r z is equal to r e की power iota theta, where r is equal to modulus of z and theta is the argument of z. What is argument of z? Our principal argument of z. And we know from our knowledge of principal argument that principal argument always lies between minus pi and plus pi. Is that fine? Now, if we take a transformation where we increase our theta to theta plus 2 pi, and your function, let's say z, now becomes what? Initially, z was what? Z was r comma theta. And now let us say z becomes r theta plus 2 pi. So it will becomes e की power iota theta plus 2 pi, and r will remain at its place. So it becomes what? R e की power iota theta only. So which is equals to z r comma theta. So basically, if you take a transformation where you increase theta by theta plus 2 pi, your z remains the same. Is that fine? Now, a function is said to be single valued. Is said to be single valued. A function is said to be single valued if f satisfies the condition that whether you take the image of z at r comma theta, or whether you take the image of f at r comma theta plus 2 pi. If both of these things remain same, then we say that the function is single valued. Otherwise, we'll say that function is multivalued. Give me a minute. So again, I'm coming back, don't worry. What I want to say, if you are moving your theta to theta plus 2 pi, it doesn't change the coordinate z. So z will remain the same. You know that z is equal to what? Z is equal to r e की power iota theta. And if you add 2 pi to it, it is not going to change anything. So basically, if you take a complete one rotation also, you are coming at the same point. The point is this: the function, if function remains the same, that is fz at r comma theta is equals to fz at r comma theta plus 2 pi, then we say that this particular function is single value. Otherwise, it is said to be multi-valued. Now, what is multi-valued? I'll give you examples and then you will be able to understand. Otherwise, function is said to be multi-valued. Is that clear or not clear?
Yes, sir.
Okay, so now let us take examples and try to understand what I want to say. So example number 1, I'm taking z raised to power n, where n belongs to some natural number, let's say. Okay, now, so basically, we know that we have already established the fact that there exists the nth power of a complex number. This is something that we have already established. So now let us try to take fz at r comma theta. So what it will be equals to? It will be equals to r raised to power n e की power iota n theta, right? And now if I take a rotation of theta plus 2 pi, that is now if I add theta, instead of theta, if I write theta plus 2 pi, what I'll get? I'll simply get r raised to power n, e raised to power iota n theta, and e raised to power iota 2n pi. Is that fine? This is what you're going to get. Instead of theta, if I write theta plus 2 pi, this is what I'm going to get. And I already know what is e power iota 2n pi. If n is integer, in fact, not only natural number, even if n is integer, then also we know that e power iota and 2 pi is what? It is equals to 1. So it will come out equals to r raised to power n e raised to power iota n theta. So clearly, fz at r comma theta is equal to fz at r comma theta plus 2 pi. So clearly, this is a single valued function. Now, what if n doesn't belong to integer or n doesn't belong to natural number? Then I can clearly write that e power iota 2n pi will not be equals to 1 for that matter, will not be equals to 1. Because what is e power iota 2n pi? You should understand e power iota 2n pi is nothing but it is equals to cos 2n pi plus iota sine 2n pi. Now let us say if n is equal to half, then if n equals to half, then it is equals to cos pi is -1, and if I write half here, so then it is equals to 0, so then it will be equals to -1. So it is no longer going to be 1 if n doesn't belongs to, right now I'm writing natural number, this can also be extended to z. Is that fine? So it is not going to be equals to 1. If it is not equals to 1, then clearly fz at r comma theta would not be equals to fz at r comma theta plus 2 pi. I'll give you example, don't worry. So basically, if n doesn't belongs to natural, then the function fz is equals to z raised to power n would be a multi-valued function. Okay, then the function would be a multi-value function. Let us understand it with another example. Let us say by example only, let me take n equals to 1 over 2. Let me take n is equal to 1 over 2. Now, if I take n equals to 1 over 2, now if I write, what would be fz then? Fz will be equals to z raised to power 1 upon 2. Okay, z will be equals to, fz will be equals to what? Z raised to power 1 upon 2. Now if I take z, simply z is equal to r e की power iota theta. So what would be fz? Fz would be simply root over r e की power iota theta by 2. Fine. Now, if I take a transformation where theta is rotated and now theta becomes theta plus 2 pi, then f at z r comma theta plus 2 pi would be simply equals to what? It will be equals to root over r e की power iota theta upon 2 into e की power iota pi. And what is e की power iota pi? E की power iota pi is simply -1. So it will be equals to minus root over e की power iota theta by 2. So clearly, fz at r comma theta is not equals to fz at r comma theta plus 2 pi. So by definition, this is a multi-valued function. Is that fine? This is a multi-valued function. I hope it is clear till now. Is that fine? Not fine. Am I audible? Am I audible? Not audible. Is that fine? Okay. So, okay. So, chalo. Next, so this is the definition for multi-valued function so far. So let us take another example. And so another understanding you have to make from here itself, I have written already, but still I'm giving. If W belongs to a set of complex numbers, a set of non-zero complex number, then for all n belongs to natural, the equation z raised to power n equals to W has exactly n solutions in C. Has exactly n solutions in C star. Okay, so this is something that you should remember. So we know that there is existence of nth root of a complex number. You know that. So basically, if you take what you can write. So if you take z is equal to some r e की power iota theta, and let's say w is equal to some r1 e की power iota, let's say phi, then you know that r raised to power n e की power iota theta upon e की power iota theta n will be equals to r1 e की power iota phi. Okay. So from here you know that what is r1? R1 is nothing but r raised to r1 is nothing but r raised to power n, or simply r is equal to what? R is equal to r1 raised to power 1 upon. Okay. And from here, by comparison, you know that what is phi? So clearly, n theta is equals to phi plus 2m pi. So you know that if you have to compare this, see, e की power iota theta is equal to e की power iota phi. I've told you before also, it is equals to theta plus phi plus 2m pi. Most general solution for this is this, because you know that uh, if you rotate it by 2, if you rotate it by 2 pi, 2m pi also, then also things will remain the same. So most general way of writing it is this. So n theta will be equals to 5 plus 2m pi, where m belongs to integer. Now from here, you know what is theta? Theta is simply phi upon n plus 2m upon n times pi. So clearly, you know your z raised to power n is equals to w. It implies that z is equal to what? Z can be equals to r1 raised to power 1 upon n times e की power iota phi upon n plus 2m upon n times pi. Okay, so in totality, it has how many solutions? It has n solutions. So clearly, you know that, and it also implies that there is existence of nth root. It implies what? There is existence of nth root. So this is clear. I actually directly started from z raised to power n. I forgot to tell you that there would always be solution corresponding to z raised to power n equals to w. So there would be some complex number associated to z raised to power n always. And there would be in totality n solutions to such equations in C star. Okay, is that fine? And the solutions are, if n belongs to natural, then this particular function would be single value. If n doesn't belongs to natural, then it will be a multi-valued function. So z raised to power n would be a multi-valued function in general. Another function which we are going to see in great detail as we go along, but right now just giving you a little bit hint. If 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 let's say z belongs to set of complex numbers, I'm writing C star, it implies what? Set of complex numbers except 0. Okay. Then let us define what would be log z. What would be log z? So we are going to take different classes on log z, don't worry. But right now, just to give you an example of a multi-valued function, I'm defining what is log z. Okay. So how to go about it? So log z is equals to what? If I take z as r e की power iota theta, if I take r is equal to e की power iota theta, what is r? R, you know, it is equals to modulus of z, and you know the theta is nothing but it is equal to argument of z. Or argument of z can also be written as principal argument of z plus some 2m pi. You know that argument of z is a general in general sense we are writing. So we can write argument of z as simply principal argument of z plus 2m pi, where m belongs to z. Is that fine till now? So your log r e की power iota theta, log behaves the same way. The definition, I mean, the properties remain the same, iota theta. So it will be equals to log of modulus of z. So what is log z? Log z is nothing but it is equal to log of mod z plus iota 2m pi plus principal argument of z. So how many values for a single z? You have infinitely many values of log z. For a single z, you have infinitely many values of z. Okay, so clearly this function is a multi-valued function. So by definition of function multivaluedness, this function is a multi-valued function. Is that fine? And similarly, it gives us another way of writing the same thing. E की power z is equals to w has infinite solution in C star. Is that fine or not fine? So in general, if we want to define we can define complex functions in two ways. So to just summarize today's lecture, we have only done what is single valued functions and what are multi-valued functions. So let's say if we take any domain, let's say D be a subset of C, let D be a subset of C, and let function be defined from D to C, then if F is a rule which assigns each value in D to a unique value in C, unique value in C, unique, then this function is called a single valued function, a single valued function. Okay, but if this uniqueness is not there, if uniqueness is not, all other things remain the same. If uniqueness is not present, that is, if F is a rule which assigns element from D to C and the image is not unique, then we can certainly say that these functions are multi-valued functions. These functions are multi-valued functions. So in multi-valued functions, what you can say, let's say logarithmic function. So logarithmic function was equals to what? Log of mod z plus iota argument of z. And what is argument of z? It is equals to log of mod z plus iota principal argument of z plus 2m pi. Now, if we restrict our function to only principal argument, if we restrict our argument to only principal argument, then this function will become a single valued function. Then this function will become a single valued function. And this value is called as the principal value of the function. This value is called as the principal value. If we restrict ourselves to what? If we restrict ourselves to the principal argument, then this value is called as the principal value. So let us say if we are having, if we want to find the solutions of, if we want to find the solutions of e की power z is equal to w, and if we restrict ourselves to the principal argument, then obviously the value would be principal value and that would be a single value. For example, just give me an idea. What will be the principal value of, just giving you two examples, what will be the principal value of iota raised to power iota? What will be the principal value of iota raised to power? So the principal value of iota raised to power iota is what? So let us say I'm giving you one simple thing. So whenever you get something like z raised to power alpha, okay, here z belongs to what? Here z belongs to set of complex number, and let's say alpha also belongs to set of complex number. Z belongs to set of non-zero complex number. Okay, so that problems won't arise. If this is the case, then obviously you can write z raised to power alpha is equals to what? You can write e की power alpha log z. Fine. So it will be equals to what? E की power of alpha. And you know what is log z? Log z is simply log modulus of z plus iota principal argument of z plus 2m pi. So this is the general value. So this is the general value. But if you want to write the principal value, then it will be equals to e की power alpha log mod z plus iota principal argument of z. So this is your principal value. Now, if I'm asking you principal value, now how are you going to start? Now let us start with whatever prescription I've given to you. If I'm writing iota raised to power iota, I can as well write it as e की power iota log iota. Is that fine? I know it is equals to e की power iota. And what is log iota? Log iota will be log of 1. Okay, what is this? Log mod z. And what is z here? So z is iota, alpha is also iota. So log 1 plus iota pi upon 2. Because you know that what is the principal value? What is the principal argument of iota? So iota is where? Iota lies in this axis. So principal argument is pi by 2. Principal argument I'm saying. Principal argument in this iota. So it will be equals to e की power iota. Log 1 is 0, you know already, plus iota pi by 2. So it will be equals to e की power minus pi by 2. So the principal value of iota raised to power iota is e की power of minus pi by 2. Is that fine? I hope it is clear. Okay, so I'm leaving you with two questions. What would be the principal value of 1 plus iota raised to power 1 plus iota? Tomorrow we'll start our session from here. And I really want to find what will be the real part of principal value of 4 raised to power 4 minus of iota. What is the real part of principal value of 4 raised to power 4 minus iota? So both of these questions I'll be looking forward. And I hope you got the gist of the lecture. Today we have done nothing, just started with functions, and we have defined what is called as a single valued function and the multi-valued function. So in the next class, we'll define the notion of limits, continuity, and differentiability. Separately, we are going to have a lecture on power series also. So I hope you are getting a lot of benefit from these lectures. Till then, take care. Bye-bye.